Hello, I think we're back. And yes, this is the board I'd like. All right, I'll get right to the point. The answer to the true false question was false. Is that what you put? Let's review the question. The question was true or false? Energy is continually being recycled through an ecosystem. There is no need to input new energy to sustain an ecosystem. And the answer is false. So let's explore why. What we talk about, what we have is a one-way flow of energy through the ecosystem. Again, energy is only trapped at the level of the producers through the process of photosynthesis. So here we have photosynthesis here. 6 carbon dioxides plus 6 water plus light energy yields glucose C6H12O6 plus oxygen gas 6O2. The energy is passed up through the trophic levels of the food chain. But remember, every step of the way, some energy is converted to heat. Light is a shorter wavelength, more energy, visible light. So this is visible light right here. Visible light, shorter wavelength of electromagnetic energy, more energy. Energy leaves is infrared. All right, I don't really like using blue for infrared. So energy leaves as heat or infrared energy. So again, whether this happens 5 seconds after it's converted into chemical energy through photosynthesis by the algae, or whether it happens 5 million years later. So the energy always leaves the ecosystem as infrared, as heat. So we talk about this one-way flow of energy through an ecosystem, through a food chain. It enters as visible light. My geology friends always call this short-wave radiation. And as I said, whether the algae releases as metabolic heat 5 seconds later, or whether it goes up the food chain, is stored as fossil fuels, and released 5 million years later, 100 million years later, sooner or later, this energy that is captured as light energy is eventually converted to infrared or heat energy, which has a longer wavelength and is less energetic. So even though there is this one-way flow of energy through an ecosystem, this energy is not recycled. If this energy were being recycled, then the algae could reuse the infrared for photosynthesis. So can that happen? Can the algae use heat? Can it heat waves? Can it use infrared for photosynthesis? Absolutely not. If that were true, you could take your algae, put it in a jar with water, of course, with a trout, and put it in the dark. And if that were true, the algae could photosynthesis from the body heat of a trout. And that does not happen. You can try this at home. You can take your favorite plant and your pet hamster and lock them into a dark closet. And if this were true, plants would be able to take the body heat from your pet hamster and use it to photosynthesize. So, energy is not, the moral of the story, energy is not recycled through an ecosystem. That has we have a one-way flow of energy, always entering as visible light and always leaving, whether it's 5 seconds later or 500 million years later, as heat, as infrared. All right. I left off a little bit part of this system. I left off the decomposers. All right, because a sad part of our story is this. Sooner or later, the algae, the minnows, the trout, and the osprey, they will all die. And when they die, there's a lot of atoms in their body. Specifically, there's all the molecules of life, the organic molecules, the proteins, the carbs, the lipids, the nucleic acids. And what happens, the decomposers break down the organic molecules, break down the proteins, the carbs, the lipids, everything. And they break them down to get their energy, and they break them down into simple inorganic molecules. Do you know what they are? Well, the products of decomposition are always carbon dioxide, water, and do you remember what NH3 is? This is ammonia. So these are the products of decompositions: water, carbon dioxide, and ammonia. So my question to you is this. It's a variation on the one I just asked. True or false? Atoms are continually being recycled throughout an ecosystem. There's no need to input new atoms to sustain an ecosystem. Now this time you might be thinking true, and you are absolutely correct. So remember, I keep using this phrase CHNOPS. These are the 6 elements that make up over 96% of the body atoms in the bodies of all living organisms. So yes, the decomposers break down the organic molecules, the proteins, the carbs, the lipids, the nucleic acids, into the simple inorganic molecules of water, ammonia, and carbon dioxide. And can a plant reuse the water molecules and the carbon dioxide molecules for photosynthesis? Absolutely, they can. They will use those and they will make those into organic molecules and they will be broken down again. So these atoms are used over and over and over again. Every molecule in every atom in your body has been part of other living organisms and part of the abiotic environment. All right, so I want to now move into three different ways to view photosynthesis. Photosynthesis, I call plants and photosynthesis the Rodney Dangerfields of the ecosystem. Rodney Dangerfield was an old-time comedian, and he was famous for the line, "I get no respect." So everybody loves animals, especially mammals. We think they're all warm and fuzzy and cute, but plants, we say, oh, plants are boring. And this is tremendously disrespectful for plants. So let's go over the three ways that photosynthesis is not only extremely important, but essential for the life of the biosphere on planet Earth. Okay, the first way was the first way we talked about. Photosynthesis captures energy for the entire ecosystem. So again, this is why the producers are called producers. They trap energy and they store it in food, which not only feeds themselves, but it feeds the entire ecosystem. Let's not get into the habit that think plants make glucose for animals. No, plants make glucose for themselves. They will break down glucose by the process of cellular respiration because they will use the energy it releases. But fortunately, they make enough not only to feed themselves, but they make enough food to feed the entire ecosystem, the entire food chain. So again, this is the first way that photosynthesis this is one way to view photosynthesis, that it traps energy for the entire ecosystem. The second thing is this. Even though we have all these chnops, we tend to focus on the carbon in biology, in organic chemistry, where are carbon-based life forms. Now, let's think about this. We eat food to get energy and to get the atoms of life. Now, can you do this? How did you grow from a little boy or girl into a big man or a woman? Could you suck in carbon dioxide, inhale it, and make it part of your body? Could you make it part of your lipids, your proteins, your DNA, your carbs? No, we cannot do this. We cannot just inhale carbon dioxide and make it part of our body. But that is exactly what plants do. They intake carbon dioxide through the process of photosynthesis, and these carbon atoms here become the carbon atoms of glucose. All right, and this really important process is called, so this is part 2, carbon fixation. In biology, when we use the term fixation, it means taking an element that's in gaseous form and converting it to a form that's usable to a life form. So we cannot, no animals can inhale carbon dioxide and make it part of their body. But that's exactly what plants do. They take in gaseous carbon dioxide and they originally lock it into glucose. If you've run Sam Spud, what they do after they get glucose, they can link hundreds of glucoses together to make starch. And they can link hundreds of glucoses together to make cellulose. The wood of a tree is mainly cellulose. Once they have glucose, they can convert it to amino acids. So when you look at a tree, you look at all the wood. All that wood is what? Billions and trillions of molecules of cellulose. And each molecule of cellulose is hundreds and hundreds of molecules of glucose. And each of those hundreds and hundreds of molecules of glucose has 6 carbon atoms. And every single one of those carbon atoms used to live in the atmosphere as part of a molecule of carbon dioxide. Sometimes if you might talk to a little kid or even an adult, you see a big tree growing from just a little, a little seedling. And where did all these extra atoms come from to go from a little tree to a big tree? And if you ask a little kid, you might think, oh, well, the roots get the extra atoms from the dirt. But if that's true, why isn't there a big hole underneath the seedling as the tree goes? No. Most of the atoms to go from a little tree to a big tree come from the atmosphere. All right, the tree incorporates the carbon and the oxygen from the atmosphere into its body. And this all starts by making glucose. So again, once carbon is fixed by the producers through the process of photosynthesis, the carbon can be passed up through the food chain onto the decomposers, which then unfix it and re-release it as carbon dioxide. But once carbon is fixed, the whole food chain, the whole ecosystem profits for it. So once again, through the process of photosynthesis, number one, the process of photosynthesis traps energy for the entire ecosystem. Number two, the process of photosynthesis fixes carbon for the entire ecosystem because all the animals, all the decomposers, they are carbon-based life forms. And none of us are able to suck out carbon dioxide, and make it part of our body. There is a third reason that photosynthesis is important. And this is what I and other scientists call a happy accident. If the plant could think, from the plant's point of view, the goal of photosynthesis is to make food. In other words, to trap sunlight and to fix carbon. But in the process of photosynthesis, it needs some low energy hydrogen atoms. If you've had Bio 151, you know that. So in the process of photosynthesis, to make the sugar, it needs a source of low energy hydrogen atoms to excite and use to make sugar. And it uses hydrogen atoms from water to make the glucose. All the plant is after is the hydrogen atom. So when it splits the water, oxygen is accidentally released. It's released as a byproduct. If the plant could think, this would not be a goal of photosynthesis, but it is a very important product of photosynthesis. So the third way to view photosynthesis is this is the process that produced oxygen gas for the planet and continues to do so. There are some bacteria that run photosynthesis, but instead of using water, they use hydrogen sulfide, and then sulfur is released. And that doesn't smell nearly as good, and it does not have the value that oxygen gas has. So, you may remember that the original Earth's atmosphere had no oxygen. It's just that cyanobacteria, for literally hundreds of millions of years, literally billions of years, photosynthesized and cranked more and more and more and more oxygen gas into the atmosphere. That's the original cyanobacteria. And now today, all animals and all plants use oxygen for cellular respiration to get the energy out of glucose. Without the development of oxygen atmosphere, there would be no cellular respiration and there would be no complex life forms on the planet. You'd have simple bacteria, simple cyanobacteria. So, again, photosynthesis is a highly underappreciated process, and the three lenses to view photosynthesis are, this is the mechanism, again, do you see how I think this is important? This is the process that traps energy, not only for the producers, but for the entire food chain, the entire ecosystem. It's the process that fixes carbon, not only for the plants, not only for the producers, but also for the entire food chain. And finally, as what we call as a happy accident, photosynthesis produces oxygen gas. So, maybe this is review, and hopefully you learned a little bit more than you learned when you talked about food chains in 4th grade. I'll see you in the next module.